In this video, we will be proving trigonometric identities. Here are some general strategies for proving an identity. The first thing you want to do is begin with the expression on one side of the identity, and then the proof will end with the expression on the other side. And the proof in between will be a step-by-step sequence going from point A to point B. Let's start with an algebraic identity. If we want to prove that this statement here is equal to 2x, we would just multiply. We'll get x squared plus 2x minus 2 minus the quantity of x squared minus 2x plus x minus 2. All of that is equal to 2x. So x squared, combining like terms here, plus x minus 2 minus x squared minus x. Oh, that was 1x. So that's minus x minus 2 is equal to 2x. X squared plus x minus 2 minus x squared plus x plus 2. So the x squared minus x squared, x plus x is 2x, minus 2 plus 2 equals 2x. And there we have an algebraic identity. In general, when you are proving an identity, you want to begin with a more complicated expression and work toward the less complicated expression. It doesn't really matter whether you're going from the left side or the right side. You're just working from one to the other. If you don't know what to do, change it all to sine and cosine. And don't forget by combining your fractions with a common denominator. Now we'll take the same idea and prove a trigonometric identity. We'll start off with expanding cosine x minus sine x squared. So this would be cosine squared x minus 2, and we can put it sine x cosine x or cosine x sine x, but since we're trying to match up this side, we'll put it as sine x cosine x. And then we have a minus sine x times a minus sine x, which gives us plus sine squared x. We want to bring our cosine squared x and our sine squared x together. So we have cosine squared x plus sine squared x minus 2 sine x cosine x. Cosine squared x plus sine squared x is 1 minus 2 sine x cosine x, which is what we were trying to prove. Here's another trigonometric identity. It is written as a joke, but it will actually work out. Sine b over tan b equal to cos b. So if we're going to solve this, we would rewrite the tan b, the tangent of b, as sine of b over tangent is sine b over cosine b. We're dividing by a fraction, so we'll multiply by a reciprocal, which gives us sine b times the reciprocal, which is cosine b over sine b. And this would be sine b over 1. Those would cancel out, and we're left with cosine b, or cos b. Another way to prove an identity would be to set up a difference of squares. For example, if we have sine x over 1 minus cosine x, we could multiply it by 1 plus cosine x over 1 plus cosine x. We'll leave the top for right now, and we'll multiply the denominator. Difference of squares is going to give us 1 times 1 is 1 minus cosine squared x. 1 minus cosine squared x equals sine x. So we have sine x times 1 plus cosine x over sine x, sine squared x. And one of the sine x's will cancel out. So we are left with 1 plus cosine x in the numerator, and one of the sine x's left over, which is what we were trying to prove. When you're trying to set these up, looking at the direction that you're going to go to, we're starting with 1 minus cosine x, and we're ending with 1 plus cosine x, which will give us a clue of setting up a difference of squares by multiplying by 1 plus cosine x over 1 plus cosine x. One more thing, or two more things to think about in proving identities. This is going back to the difference of squares. Keep that in mind when you're proving an identity, and always look at where you're aiming and choose things that'll send you that direction. And if you're truly stuck, try starting at the end and working back toward the beginning. And just for fun, look at this equation. 61 minus 8 plus 8 plus 8 plus 8 plus 8 equals 8 plus 8 plus 8 plus 8 plus 8 minus 19. And if you read it upside down, it still makes sense. See you in class.